This is the Semester 2 Finals Review Packet, Units 5 and 6 help video. Going to give you a little shove. This is Unit 5, of course, is all things right triangle. So if you have anything other than a 30, 60, or 45 angle, you're going to be using SOHCAHTOA. So once again, just as a reminder, you start by sweeping your theta, which is your given angle, which in this case is 41. Then you label your opposite side, which is across from theta, your adjacent side, which is next to theta, and then you have your hypo. And we do have need, do. And in this case, we have the hypo. We need the adjacent. That's an AH combo, so that goes with cosine. So that's cosine theta over 1 equals adjacent over hypo. Always write your equation out. Therefore, it's going to be cosine of 41 degrees. Keep parentheses around that. Equals adjacent, which is x, over hypo, which is 20. Cross multiply. Remember, do not touch a calculator until your variable is by itself. Taking here, we're using to find theta. We have, this would be adjacent, this would be opposite, and this would be your hypo. You have all three, so you could technically use all three. So I could use inverse sine, opposite over hypo gives us theta. Inverse cosine, adjacent over hypo gives us theta. Or inverse tangent, opposite over adjacent gives us theta. When you have all three, you could use all three. All right. 45, 45, 90, leg, root 2. And 30, 60, 90, short leg, root 3, short leg times 2. So going here, 45, 45, 90, leg, root 2. So on this first one, our chart is leg, because that's a 45, 45, 90. 45, 45, 90, leg, root 2. Legs are equal. And going from the leg to the hypo, we times by root 2. And in here, we have 30, 60, 90. Short leg, we start with the short leg. Short leg to the long leg is root 3. Short leg to the hypo times by 2. So taking a look here, leg, this is 7 root 3, this is 7 root 3. Going times root 2, always show your work. Don't try to do that in your head. So it's going to look like this, 7 root 3 times root 2, which is going to make this, of course, 7 root 6 right here. And we have here short leg root 3. So it reads like this. Something times root 3 is 7 root 6. That's what that looks like. So you're going to divide out the root 3. Only innies talk to innies, outies talk to outies. So that something is going to be 7, and the 3 goes into the 6 and twice. So that's going to be root 2. So our something here is root 2. You can take it from there. What do you need to remember here? You got a four-sided shape, and all four-sided shapes of any stripe, convex four-sided shapes, add up to 360. We have ourselves a parallelogram. What do you want to remember a parallelogram? OCD. Opposite, 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 consecutive, diagonal. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles add up to 180. Diagonals bisect each other. So OCD, opposite sides are parallel, which means you need to watch out for armpits of the Z being congruent. Opposite sides are also congruent. Opposite angles are congruent. Consecutive angles, these squiggle ones, add up to 180. And of course, if you draw on the diagonals, they bisect each other. Trapezoid, a couple things you want to remember about a trapezoid. Because we have one set of parallel lines, and one set of non-parallel lines. Remember, the parallel lines give you consecutive interior angles, which means these angles connected to the parallel lines are the leg angles, add up to 180. Another thing to remember is all four, of course, still add up to 360. In this particular case, you also have an isosceles. So you have two equal sides. You're going to have two equal angles. Two equal sides, two equal angles. Find the length here. We are given medians. So the median, that is a median. It connects the midpoints. There should be hatch marks there. I guess they didn't photocopy. But we know the median equals the average of the bases. So base plus base over 2 equals the median. Find the measurement missing. Keep your answer the nearest tenth. You want to watch out here for a switch in units. Just be careful with that for switch in units. Or you have to work backwards. That's why you always want to write an equation with two sides and an equal sign. For example, here you have a trapezoid. We want to find the area of a trapezoid. And area is going to equal base plus base over 2 times the height. And you take a look what's having here. You want to get really close. Now, careful. It looks like that 4.2 is the height. That is not. There's no right angle there. You got to watch out for that. That is not the height. Your height is going to be here. And your height is currently unknown. But you do already have the area. So you're going to have to work backwards. That's why equations have two sides with an equal sign. So 23.1 equals base 8 plus the other base 3 over 2 times that height. And you solve for your unknown. It says find the interior angle sum for each polygon. And the song goes, the sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides. Ain't this fun? The sum of interior angles. Sides minus 2 times 180. The sum of interior angles. Sides minus 2 times 180. Take it from there. Count your sides. Plug it in. Find the measure of one interior angle, and it's regular this time, which means all of these are the same, the sides are the same, and the angles are the same. So the song goes, each angle of a regular polygon, sum over sides, ain't this fun? So this interior angle is going to be sum over sides. And then if I'm asked for the exterior angle, that's also sum over sides. The difference is this is interior. The sum of interior angles, sides minus 2 times 180. That's for interior. And minus 2 times 180. Exterior. Sum of exterior angles will always be 360. That's for exterior. Find the area of each regular polygon. Leave your answer in simplest form, which means no decimals. That's another simplest form is another way of saying exact form. So regular means all the sides are equal. And in this case, the regular polygon is going to be perimeter times apothem over 2. Perimeter times apothem over 2. And so the problem here is you only have the side lengths. So you're like, how do I manage that? Take a look here. Obviously, we need to ask ourselves, what do we know? And if all 3 sides are equal, all 3 angles are equal, which makes them 60, 60, 60. And I need that green apothem. Keep in mind, an apothem has a right angle, which means you can make yourself a right triangle, but more specifically, a 30, 60, 90. Short leg, root 3, short leg times 2. So be very careful with this. Your short leg is going to be here. We need that. That's going to be your green apothem. Whatever this is right here is going to go there. Problem is you don't have it. So let's start with, what do you have? We have this side length. Careful there. Simplest exact form, no decimals. That means that squiggle side length needs to be 11 root 3 over 2. Yeah, leave it. All right. Now, 30, 60, 90. Pull it out here. 30, 60, 90. Short leg. Going this way, short leg root 3, short leg times 2. If this piece is 11 root 3 over 2, you ask yourself this. This is the original. What times root 3 is 11 root 3 over 2? And it's pretty easy to see the only addition here is the root 3. So if you were to divide that out, you would end up with 11 over 2. Now you have everything you need. Don't be afraid of the fractions. They're not going to eat you alive. Our perimeter is going to be 11 root 3 times 3, of course. All of that is just your perimeter. Your apothem is 11 over 2. And the whole thing is over 2. You simplify it from there. All right, I'm going to change it in the margin. We're going to go 33 root 3 over, that's the 11, times 11. That's that times 11 over 2 divided by 2. And you take it from there. Translation, 5 units to the right, 5 units up is to the right, just means positive. 1, 2, 3, 4, 5. And 5 units up, 1, 2, 3, 4, 5. You bunny hop everything. Reflection across the y-axis. To reflect across the y, you opposite the x-coordinate. So whatever the x-coordinate is, just opposite and take it to the other side. That's reflection across the y-axis. Rotation about the origin, whatever your coordinate is here. Okay, technically you know that this is going to be a positive x and a negative y. A 180 rotation takes you to the exact opposite. So that's going to be negative x and positive y. You just go to the exact opposite for 180 for both x and y. Rotating 90 about the origin. You switch and flip the sign depending on whether it's clockwise or counterclockwise. So clockwise, you would go like this, y, x, and then you would flip the sign to the right. Counterclockwise, you would go y, x. Counterclockwise, you would flip the sign on the left. Here you look at it, you determine what the transformation is. Graphing a line, very important. The goal here is to get y by itself and turn it into y equals mx plus b. So our goal is to get y by itself. So the first thing I'm going to do is I'm going to add 75 to both. And taking a look here, that's going to make it, I'm going to rewrite it. So most of us are familiar with it like this, minus 15, y equals 75. Then I'm going to get rid of the x couple here to both sides. So I have negative 15y equals 27x plus 75. The opposite of timesing is dividing. And we have y equals 3 goes in there 9 times, 3 goes in there 5 times, and it's negative, which means our line's going to go down from left to right. And that's negative into a positive, so that's going to be minus 15 goes in there 5 times. So that means you're going to start at negative 5 and then count out your slope. You're like, but wait, I can't go down. If you can't go down, you can go up this way and just make sure the line tilts negative. We want to write a slope-intercept equation of a line, y equals mx plus b here, with the line described. So we want it to be perpendicular to this line, but go through this point. So I start with y equals mx plus b. And I ask myself, what do I have? Well, I have an x coordinate right there. Put a 1 there. I also have a y coordinate right there. Put a 4 there. My given slope is negative 1/9. So perpendicular slopes are opposite reciprocals. So my perpendicular slope is going to be positive 9/1. This is going to be multiplying plus b, which is my unknown. And you simply solve, of course. So I have 9, 4 plus b, -9, -9. And b is going to equal -5. So my equation is y equals 9/1x minus 5. Now, just to make sure, what I recommend is you actually graph these lines. Let's do a quick sketch here. Do this one. See if you're correct. So +3, 1, 2, 3. There we go. Up 1/9, and it's a negative. So up 1/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This isn't going to be exact, of course. It looks something like this. And this one is going to be -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. Okay.
Oh, we lost him. I think Hamilton's group might have won. There was actually a shootout at the end.
All righty here. So you can see if you graph this accurately, it'd be a lot more accurate. So our given point is 1,4. So that's about, let's see, 1, 2, 3, 1,4. It's about right there. I'm a little off, but my slope is 1/9. And if you graph this accurately, it is going to make a right angle. Check your answers here. It is very important. When you check your answers, just if it's correct, star, smiley, check. But I also want, in every single one of these, a little note. What do you want to remember? What do you want to remember?